Hi folks, the purpose of this lesson is to introduce the idea of an abstract class. Now an abstract class turns out to be a really useful construct in Java that's sort of between, it sort of has behavior that's similar to say inheritance, but also similar to polymorphism when it comes to dealing with interfaces. So an abstract class, you can think of it as somewhere between a real class and an interface. And so we'll see how, what exactly that kind of means as we walk through a simple example here together. So here, I thought I would just start with some code that uses an interface, and so let's look at that first. So I have this interface fruit, and it defines two methods, isCitrus and getName. So isCitrus will just, the idea there is that an implementing class will return true or false based on whether or not that fruit is a citrus, and getName will return the name of the fruit. I have a couple of classes that implement this interface. I have a peach class. It has a private string name equals peach. It has isCitrus, which just returns false, and it has a getName, which returns the name of the fruit. And then an orange class, which does something pretty similar. The only difference here is that it is a citrus fruit, so it returns true, and then its name is orange. So I have a fruit stand class that just is kind of my kind of functions to hold my main method here, apart from the other classes. So let's go ahead and run that. Right, so you can see that all it does is it creates a couple of fruit objects, one of type orange, one of type peach, and then it prints out the results of their getName method. So in particular, fruit 1 is an orange. As we see, we've created an orange up here. Fruit 2 is a peach, as we can see there. And so there we go, nothing that complicated. So one thing I want to do here is I actually, I could have done this before, but this is a useful lesson to do it right now while we're together, is that I've declared fruit 1 and fruit 2, these two local variables in my main method. I've declared them as type orange and type peach. However, they each implement the fruit interface. All right. So one of the benefits of using interfaces is that we can declare things of types that correspond to those interfaces. So I can declare this as a fruit. Each of these I can declare as being of type fruit. Now that's very useful because as long as I'm only using the methods and properties, or the methods rather, that are defined in the fruit interface, I can use this more generic typing, and that kind of gives my code more flexibility. So the more abstract, the more flexible, the more polymorphic we can be, the better off we are. So if, in particular, if I had wanted to put something in an array list, if I wanted to create these things, I could do that, and I could store a bunch of different types of fruits, an orange and a peach, in an array list if I use the fruit type. However, I would not have been able to do that if I use the concrete types orange and peach themselves. So that's just how that polymorphism works in that example. Let's go back to our fruit interface. All right, so fruit is a useful interface. We can't actually create a fruit object, which is good. There's no actual real meaning to having an actual object that's just a generic fruit, right? We can only have specific fruits like oranges, peaches, apples, berries, etc. We can't have just some kind of abstract idea of a fruit. However, I would like to be able to kind of wrap up some of these common behaviors that are in each of my peach and orange classes and put those in something that they could inherit from. So here I have, this isCitrus is doing mostly the same thing in each. The Boolean that it's returning is slightly different, but the same behavior is in place. And then getName is exactly the same between these two classes, right? So in one class and the other, they're exactly the same. They're just returning the value of this.name. So what I'm going to do is I'm going to come back here and I'm going to convert my interface into an abstract class, and that will allow us to pull up these common behaviors into a class that peach and orange can each inherit from, while also preventing somebody from actually creating a fruit object. So let's see what that means. I'm going to declare this public abstract class fruit. Okay, so now I got some warnings here. In particular, I need to provide implementations for these things. Actually, I don't have to do this one first. Let's just do a quick. I'm going to declare these methods as abstract. That'll take away all the warnings in fruit here, and I'll tell you about what that does in a second. But first, let me go out here, and here I'm in my peach and orange classes. They are each sort of, they've implemented the interface fruit, but I don't have an interface anymore. Now this is an actual class, albeit an abstract one. So instead of implementing, I want to extend. So if I do that, notice that all my warnings or errors in peach go away, and I can do the same in orange, and all of my warnings will go away there as well. And we can just see here that I can go ahead and run my code and make sure it all works as advertised. Great, same. So all I did there was I declared that instead of using fruit as an interface, I can use it as an abstract class. And then I came down into within the definition here, and I put the keyword abstract just after the access modifier public on each of these methods. Okay, so those are kind of two different, these abstract at the class level and abstract at the method level do different things. Let's talk about abstract at the class level. What this does is this says, hey, I'm going to create a class here, but you cannot implement it. Nobody is allowed to implement that class. If I were to come over here and say fruit 3 equals new fruit, Java's just not going to let me do that. And in particular, the warning I get or the error I get says that you cannot instantiate the type fruit. You can't instantiate it. You can't create an instance of it because it's an abstract class. That's one of the purposes of using abstract classes, is to prevent people from instantiating them. But we still get to share behavior, and we still get to share various things. So, one of the things we can do is we can share our name property. So let's say that we have a private string name. All right, and then I can define this method now. Get name, I can say return this dot name. So here's the difference between, and now that it's no longer abstract, I'll remove that abstract keyword. So again, we'll talk about what abstract means at the method level in just one moment. So here I've just added an instance property called name to my fruit class, and then I've provided the definition of the getName method within the fruit class as well. All right, so now I can come over here, and I actually don't need these anymore. So this is the point of doing an abstract class, is I can get rid of duplicated behaviors and pull those up into a parent class. Since both peach and orange are extending fruit, they can each they will each get this behavior just by extension. The one other thing I need to do is, instead of declaring my own instance of the name property, I don't want to do this because this is going to basically shadow the name property that's up in the fruit class, and I would get not what you would expect when this method runs. Instead of declaring my own property here, I don't need to do that. I just want to actually set it in the constructor. So let me create a constructor here. And I will just say this dot name equals orange in the constructor, and then I can get rid of this. Oh, and here's a good lesson. So what the compiler is telling me here is that the field fruit.name is not visible. So this is a mistake that I just made, unintentionally, but I'm glad I made it because it allows me to talk about access modifiers. Notice that up in fruit, I've declared this name property as private. Private means that only this specific class can access it. Now, if I want to be able to access it in a subclass like I am here, I'm trying to access it within the orange subclass, that's not legal because the field is private. So I would need to modify this property. And let's see, the best way to do it, there are different access modifiers. And let me go ahead and just say protected. Okay, so there's two kind of mid-level access modifiers, protected and package, and those will each allow subclasses to inherit or to see the properties within that are defined by the parent class. Sorry, got tongue-tied there a little bit. Okay, so now let's go to Peach and let's do the same refactoring here with Peach. We're going to provide a constructor. Great. All my warnings and compiler errors are gone now. And so see, now that I have a lot less code going on here, and it's also this shared behavior is only created in one spot. It's only created in the parent class. The getName method, which was basically the same, it was exactly the same in each of my subclasses, is now pulled up and shared by the parent class. Okay, so that's great. So now let's look at this isCitrus method. This one, I'll talk about the abstract keyword as it applies to methods now. When you're dealing with an abstract class, you can provide, the difference between an abstract class and an interface, let me start here, is that you can provide implementations for your methods like we just did here. Here we have a public string getName. This method is actually implemented within our abstract class. An interface does not allow you to implement behaviors. The burden of implementing a behavior is on whoever implements that interface. So we could not do this within an interface. But since here, if we want to share this code between classes that inherit from fruit, we would need to use an abstract definition instead of an interface. And that allows us to actually provide code to implement this method getName. But the thing is, we're not obligated to implement every single method that we put in our abstract classes. If I want to just say, enforce that everybody provide a method isCitrus within their own class where they provide the implementation, similar to the way an interface would work, I can do that by just using the abstract keyword. This basically says anybody that extends this class needs to implement this method, but I'm just gonna define it here. I'm gonna define the method signature here for purposes of enforcing that rule that everybody who extends fruit will be forced to implement isCitrus. So that's what abstract at the method level means. It means essentially the same thing that you would do by putting a method signature in the definition of an interface. Now here we actually can go one step further and actually provide an implementation for isCitrus that does something similar to what we did with getName and kind of removes this semi-duplicated code within our set of classes here. So let me go ahead and make a protected Boolean isCitrus. And then here I can just go ahead and provide an implementation. Okay. Now what I've done is I've done the same thing, similar thing as with name. I've just created an instance property that's protected so that the subclasses can access it. And then I've gone ahead and implemented my isCitrus method by just returning the value of that instance property. And so I can come and refactor these orange and peach classes in a similar way. Okay, so let's see. We have isCitrus true, isCitrus false. Great. And so I don't know that we need to do this, but we can just run this and see that our code works just the same as it always has. Okay, great. So now we have a full-fledged abstract class. We started with two classes that had a lot of duplicated behavior. Peach and Citrus had essentially the same behaviors within them, and we were able to similarly to when we talked about inheritance and parent classes and extending classes, we're able to pull those duplicate behaviors up into a parent class. However, we didn't want to create a parent class that could actually be implemented, or rather a parent class that could be instantiated, because fruit as a concept, as an object, we should not be able to create just a generic fruit, because such a thing does not really exist in the real world, and we don't want it to exist in our application. So we declared that class abstract. So while we're doing this implementing of behaviors, we know that nobody could ever create an actual instance of this class with these properties, because that just wouldn't make sense. So we were able to do that by extending the class in multiple ways and providing the details needed to fully flesh out those two classes, peach and orange. So what did we get out of this? We got some non-duplicated code, so we reduced code duplication within our program. That's good. We also still have polymorphism in play. We can still refer to things as instances of the fruit class. So just like with interfaces, you get polymorphic behavior. where you can define things as the type of an interface, you can also define things as the type of an abstract class. And this turns out, again, to be very useful because Java is strongly typed. We're not able to, say, put something that's declared as an orange and something that's declared as a peach within the same array list. We can do that, however, if those things are both declared as a fruit. And as long as we're only using the methods and properties within that abstract class, we will be able to type these two things as fruit rather than as their specific concrete implementation types, orange and peach. All right, so generally when you're working with abstract classes, you're probably going to do more work with creating abstract classes than abstract methods. We saw that we could create abstract methods by using the abstract keyword, which is similar to defining a method signature in an interface. So you might have something like this. I guess I need a return type here. So you could do this, and notice all of a sudden, as soon as I save, I get compiler errors on each of these classes because I have not provided an implementation for the isBerry method in each of these classes, and that's exactly what these methods are these compiler errors are going to tell me. So you can use the abstract keyword at the class level, which lets you create a class that cannot be instantiated. You can also use it at the method level, and both of these basically say someone else has to finish the work here. So isBerry is now a method that has to be implemented by any class that extends fruit. So we don't actually want this. I just did it to illustrate that idea. So let's get rid of it. So I would say most of the time, at least in this class, you're going to, most often when using abstracts, you're going to use them at the class level and be creating abstract classes that allow you to collect common behaviors into a class that can't be implemented. And that turns out to be really useful. So obviously the code you're going to create is going to be a little bit more complicated than this, but hopefully you have a feel for the concepts at play and can go out and create some abstracts of your own.